To talk about Git. Anyone here use Git on the daily already? Wow, I really apologize. You are in the really wrong room. It's gonna be pretty boring, but we'll try and make it spicy, I guess. So real quick, my name is Matthew Robinson. I do DevOps for the Kroger company, which is like code for I'm overworked and underpaid. I've been a Linux and Boss enthusiast for 12 years. I installed Ubuntu when I was like 13 and ran apt-get install, and I was like, I'm a hacker now, this is cool. So that's how I got started. And I'm also a podcaster and sort of a developer on the weekends. So, but
What's the name of your podcast?
Penguin Punch? Yeah, don't Google that though. It's not good. You don't want to see the results come up. But I'm assuming, like, raise your hand if you don't want to contribute to open source software in this room, right? All right, cool. This is gonna be good. So the thing I would say is just do it, right? Always at every single one of these Linux fests I've ever been to, there's always the talk that's like, yeah, everyone should get pumped, everyone should contribute, and you can do whatever, right? You don't need to know how to code. There's all this stuff. You can do documentation or whatever. And I always go to those, and I always get super duper pumped, right? Like I am just like ready to go after that, and I walk out of the room and I'm like, yeah, I'm going to contribute to open source. But then I realized that a couple years ago, I didn't know where to start. I got kind of stuck. I walked out of the room and had nowhere to put all that energy, so it just kind of died off. So this talk's actually going to be about Git, and that's because even though we do a lot of different technologies in open source, Git is the only one that's like used everywhere, right? It's the most ubiquitous tool we have. If you want to work on the Linux kernel or whatever, you need to understand C, you need to understand hardware code or whatever, right? But if you want to write a Python command line tool, it's a totally different skill set, right? But either one of those things, you're going to be using Git no matter what. I mean, even CPython, all these projects that were on other version control systems have now pretty much moved to Git for the most part, and GitHub, so that's where we're going to focus on that. But that's why, like, if you want to do this, you need to know Git. So some of you might be wondering, though obviously the majority of you will not be, what is Git? Well, it's a distributed version control system, manage change files over time, it's very complicated, and it does remote and local repositories, which is different, which only really matters in context of comparing it to a previous version control system. So like, who's used Subversion? Yeah, how many people like Subversion? Yeah, all right, cool, yeah, so.
It depends on what you're comparing it to.
Right. Git?
This is a version from Visual Source.
Okay, fair enough. Yeah, I would say that's an upgrade. So at Kroger, we just moved everyone to Git from Subversion. And for whatever reason, the people who work at Kroger really like Subversion. So they were really not happy with me. So my job was to make them like Git. Now, if I said all these words and you have no understanding what they mean, and it sounds like alphabet soup to you, and that's how you feel right now, don't worry. I'm going to take you through the very, very basics, the fundamentals that you need to actually use Git properly. And not, one of my favorite speakers says that Git empowers you to seamlessly screw over your coworkers, and we're going to teach you how to not do that. So this slide is mostly a reference slide. So if you were wanting to take a picture of a slide, this would be the one to take a picture of. These are the commands that you're going to run every single day that you use Git. If you understand all these commands and like at least what they do and how they work, you really know Git and you can Google your way through any problem. Kind of the trick to getting started with Git is that to understand all these, you kind of need context of what the other things do. And then to get to the more complicated stuff, it always shows up when you're like, Google, how to fix this Git problem. And someone's like, you should rebase. Someone's like, you should cherry pick. Someone's like, you should do a merge and then fix the conflicts. And you're just like, I don't know what any of those things mean. So that's what makes it really difficult. And so these are the commands, like if you understand these, you can figure out what a cherry pick does. You can figure out what rebasing is. You can figure out all the different stuff, right? You can figure out how to squash things. So we're going to go ahead and start. I'm actually going to take you through, like, basically, we're going to go through these in the order that you would use them as if you were contributing to a project. I'm going to tell you a story, and then at the end we're going to do a demo and actually contribute to an open source project on stage. And by me, I mean we. So is there any Emacs users in the crowd? All right, I'm really sorry. So let's imagine for a second that you decide that you want to contribute to Vim, right? Vim's on GitHub. So what you do is you go out to the Vim repo on GitHub, you go there and you click the fork button, and then you'll have your own copy of the Vim repo on your GitHub account. And it'll say like your username Vim instead of Vim, right? Well, the first thing you got to do to get that source code to actually work on it is you've got to clone it. And the reason we call it clone and not download is because it literally makes a copy of the repo. That's what I was talking about when I talk about being distributed, right? Everything is a repo, even your local laptop, the remote is a repo. Everything's basically identical for all intents and purposes. So just like the example there, you would go ahead and clone down your repo. And once you do that, you'll have a folder named Vim, and it'll have all the Vim source code in there. And so once you see the end of that directory, right, the first thing you're going to want to do is run git status. Git status is my favorite command. If you only remember one of them, that's the one to remember, because it's your spirit guide, right? It's going to hold your hand and take you on the journey that is using Git, because often it will even tell you exactly what you need to do to progress further through using Git, right? So it'll show you unstaged changes, unstaged files, untracked files, right? And once you stage those things, it'll tell you that they're staged, and it'll say, hey, you've got these changes to be committed, so obviously, if it needs to be committed, you should run git commit. We're going to talk about what the rest of that means in a second, but git status is awesome, so use git status. But once you get in there, right, and let's say, for instance, that you want to, I don't know, what are we going to do with Vim? We're going to go ahead and add an eLisp interpreter, right? That seems like a good thing to do. Now my Emacs config works in my Vim too. Perfect. So what we're going to do is we're going to make some changes to the source files. And once we do that, we're going to stage those changes. So let's say we go ahead and we add a new file called like elisp.c. That sounds like a really good file name. So once you do that, you've got to say, you run git status and it's red and it says, hey, you've got this untracked file. Well, to make that file be tracked, you then stage it. And the best way to explain this, in my opinion, is you have like a stack of boxes, right? And you need to load them on a truck. And the best way to do that is, like, let's say that only some of these need to go at one time. You move some of those boxes into a staging area, and then at some point someone will come along and take those boxes in the staging area and put them in the truck, right? Staging them is the git add command. Taking them from the staging area and putting them on the truck, putting a little bow on it and all that, getting it ready to ship, that's committing it, right? So it sounds hard, but what it is at the end of the day with a git commit is it'll take those changes, throw them into this mystical database that Git controls and I have no understanding of, and it puts a git log message in there and it says, these are the changes I made, right? And then here is the hash that points to the point in time that I made those changes, right? So it'll keep track of things like the date or whatever. And what's really nice about that is it makes it easy to go back to those changes and to revert those changes, okay? Writing commit messages is sometimes really hard. It'll open up the editor, which is Vi by default, which for the Emacs people is awful, and you can set that. But a git commit message is generally going to be a 50-character summary, right? And then there's a part for you to put like a longer form description. But a git commit should always be very clear about what you did. And generally speaking, they should be pretty small. And that's just general good git stuff. But the thing you might notice is that we haven't actually made a branch or any of this stuff. We have no way to keep our changes separate from other changes. So if you went ahead and made your eLisp interpreter, right, and then you were like, oh, and I need to update the version number or something, or I need to add to the README, or document my new thing, right? That's not all necessarily related. And so what you'll want to do is you actually want to use a branch. And a branch is just a way to kind of encapsulate that work as being separate from the rest of your changes, okay? So if I go in there and make an eLisp interpreter, right, but I also want to add a new Vim script function so that you can like do inline eLisp with a Vim script, that's not necessarily related, so you'll want to keep those changes separate. And the reason that this is like really, really important is how many people have like ever had your manager like email you a spreadsheet like to your entire team, he'll blast it out, and it has like 5 rows, and each row represents one person on the team, and he says, hey, I need you to fill this out for you. And then everyone fills out their row and emails him back that same spreadsheet? Yeah, I see some heads nodding. Okay, this happens to me a lot. What's awful about that is once he gets all of those back, right, he has to open up his spreadsheet and then copy and paste and do this all super manually, right? What would be much easier is for him to say, okay, here's this Git repo with this spreadsheet, everyone clone it down, make a branch for your change, right? So I would make a map branch, right? And then I'd make my changes and I'd push my map branch up. Once he has that, he can pull that down. And once he does that, he can then merge my branch in. And Git will take care of making sure that they play nice, right? So essentially what it'll do is it'll take my changes and play it on top of his version of the file. So once he does that, he then has his spreadsheet with my changes on it, and he doesn't have to do anything except just git pull, right? Everything just kind of worked. The way you do that is with the git branch command, which allows you to view, create, and manage branches, right? Delete them, etc. And then the checkout command. So if you went into your Vim repo and you said, all right, I'm going to make git branch write eLisp interpreter, right? You'll notice that if you run git status after that, you'll notice you're still on the master branch. Don't ever make changes to someone's master branch, right? Like, who's ever had a passenger like change the radio station while you're driving? That's like the analogous equivalent, right? You just don't do it. It's not nice. So you've got to check out the branch. I put in a useful flag here. That command there just does both those things in one go. So, but the best way to think about branches, right? Because it's weird to see how that kind of works in your head if you've never seen anything like that. So we have these beautiful charts, and they look kind of like Guitar Hero. You'll notice there, like at a certain point, right? Let's say that purple branch right off the bottom, someone decided to make a branch, and that's why it shoots up into its own thing. What's important to remember is that when they do that, the changes continue to happen on that bottom purple branch. Okay? They don't have that work in their branch. So when they go to merge, sometimes you'll have a really bad time. And we're going to talk about that later, but basically, there's a lot of ways around that, and that's why Git is hard, because it gives you all these ways to get out of these tight spots. But what would happen then is once you create that branch, right, no one else has that. It's all local. So then you've got to make your changes, etc., and once you commit them all, you then have to push your work up. So the super simple way that Subversion used to work, right, is there was the repo on the server, you checked it out, you made your change, you checked it back in, right? With Git, it's a little different. So what you do is you have your own version of that repo. And now that you've made these changes, you've made these branches, you've done all this like wonderful, terrible things, you've got all this, but no one else does. So you have to push those changes up. So what that does is that takes the delta of your local repo and what they have up there, the delta between those two, and just pushes that piece to them. Right? So new branches, new changes, all that stuff up there now. Once that's happened, then let's say your bro over there, who's like a hardcore Emacs guy, and you want him to try your new Vim build that does stuff. And he's like, okay, cool. So he has to pull your changes down, right? Push and pull are they're just the opposites of each other. They're identical almost in every way. Except that when you push to something, right, if that remote repo has changes that you do not have, the push will fail. And then you'll have to pull those changes first. So as long as you have stuff they don't have, you can push. Otherwise, you have to get their stuff first and then add your stuff to it. Okay? Now, the cool thing is that pull merges a branch when you pull it down. It does that automatically. If you pull in a branch that's not yours, for instance, you can pull in a different branch altogether. That's why it's called a pull request and not a merge request, if that was not making sense earlier. Moving on, what will happen is, sometimes, when you go to pull, is you'll have a merge conflict. So this happens when, like, let's say you're both editing the same file, right? They deleted something, and you still have that something, or you made changes around that same area, just close enough, right? If they push that up and it's in the remote repo, and you go to pull it down, Git does not know how to handle that situation, right? It handles additions really well because it's like, well, everyone's just adding stuff, so it doesn't matter. Let's throw it all together and we're having honky-dory, right? But when something like that comes up, it goes, I don't want to lose work, so you got to fix it. Now, there's a bunch of ways around these. You can do strategy options, you can do rebasing. Rebasing is my recommended way, that's why it's linked in the slide, which doesn't help you at all. But realize that later. But the other thing about merge conflicts is that as long as you're following like a process and everyone's kind of working the same way, you can manage your way around merge conflicts and they won't really come up that often. The other beautiful thing is that unless you're the one running the open source project, as a contributor, rarely do you have to worry about that piece, right? As long as you follow their contribution documentation, they don't really have much to say except, okay, we'll take care of the merge conflicts for the most part. But that also leads to the very important point of, if you want to contribute to a project, you should maybe read the documentation first before you do that, or else you will have wasted effort and be very sad, like I was. So, the final thing before we kind of do the demo is, where does the source code go? And the answer to that is anywhere you want it to go, really. GitHub, GitLab, Bitbucket, these are all just front ends for a remote Git server, okay? When you push to those, it's not just sitting on their box, the same as if it was sitting anywhere else. So you could, honestly, you could push to my laptop if you had that set up as a remote. You can manage multiple of these remotes. But the reason I bring it up is because GitHub adds extra things like submitting issues, and it adds a GUI on top of doing things like pull requests, etc. So you get all these additional features with something like the front end. But the important thing to note is that it doesn't do anything that you can't just do in the command line using Git or any other Git GUI. So now we're at that point. Kind of flew through it, mostly because everyone in the room already knows Git, so it wasn't a whole lot of reason to spend time on it. Let's kind of go through that process. So, can everyone read? Oh, no one else can see that. Man, that's why I wanted to mirror these, because it would be way easier. But here we are. Okay. You are not my friend. Go away. Oh, hey, look at that. Not going to get my cursor over there to maximize this. All right. Moving along. All right. And then Uno Mas. There we go. All right, that works fairly well, I would say. Okay, so I'm assuming that you were able to figure out how to sign up for a GitHub account. If you're not, I'd be happy to help you after the talk. So you go and you sign up, and you can see here, like, just put your username and password in. My username is definitely not Matthew Robinson. And you find an open source project that you want to contribute to. This is one of my open source projects, plug, plug, plug. And what you do is you go here and you look, and you're like, okay, this is cool. And you take a look through the README, see what the tool does, everything's sweet, right? And then most of the time, if they're worth contributing to, they'll have a contributing document or some kind of section telling you how to handle their stuff, right? So here you can say, just fork it, create an issue, create your feature branch, you push your branch up, and then submit a pull request, and it says there, all pull requests should go to the develop branch, right, not master. So that's really simple, really straightforward. And what we're going to do is like, okay, well, it says submit an issue, so let's go submit an issue, and you're like, oh, well, wait, the thing I wanted to work on is already here, right? And it says, should be able to remove a file from the profile easily. Here's what the command should look like since RM's already used. And the issue would be perfect for fixing at Ohio Linux Fest, which is incredibly convenient. So you have this issue, and the thing to look for is if you don't know what you want to work on, go find an issue that already exists that's really defined in scope, and if anything has like a spec of what it should look like when you're done. Because the best way to get started is to do something small, right? So my first pull request was to add block quote styling to a web app. Like, I didn't do anything except make the background gray instead of an ugly yellow and made it stand out a little better. You know what? And I feel super cool when I go see that now. That's like a little piece of me up there on the internet, you know? So I'm just like super pumped. But it was like it's a super small change. It took me like 30 minutes to make and like get it right and then send the pull request, right? 30 minutes from start to finish. And so it's really easy to just get started. And once you do that, right, it's kind of like ecstasy. Like you take it the first time, and you're like, oh, this is awesome. And you're like, I just want to keep doing that, you know? That was probably not a great analogy, but, you know, they're not inviting me back. So once you find the issue, you're like, okay, cool, hey, all right, I will work on this. So you put a little comment there, because you're not a contributor, so you can't like take ownership or anything like that. But you go ahead and say, hey, I'll work on this, so they know, hey, you know, somebody's working on this, we're not going to worry about it. So once you do that, right, the first step in the contribute documentation was to fork it. There's a clearly labeled fork button. It took me 3 days to find it. But once I did, I clicked it. Here we are. And so like I said earlier, right, you now have your own copy of that project, right? This is your special copy. No one else has this. And this is what leads to things like people forking Debian, right? You know, I don't like systemd. Let's click that button. So once you have that, you then go to the clone, right? Copy the clone URL. They have a really convenient button for that. You go back to your terminal, right? And just like in the slide, you run git clone, give it that URL. What this is going to do, network permitting? Yeah! All right. I was scared about that part. So once you do that, you'll notice that there's a DFM folder that it downloaded and created, and it even says cloning into DFM to let you know. Once you see the end of there, you see that I had a couple backup plans. I was ready. So once you do that, you'll notice, because my bash prompt is special, it says that I'm on master. But if you run the git status command, like I said, once you get in there, it tells you everything, right? It says, hey, you're on the branch master. Your branch is up to date with the remote master that you cloned from, which is origin in this instance. And you have nothing to commit working directory clean because, like, for instance, you haven't done anything. So, like, if you create a file called test, right? So now we have this extra folder, or this extra file. You run git status and it says, hey, all right, dude, you got an untracked file. You should stage that with the git add command, right? Can everyone in the back see that? Is it too far down? All right, we're going to do this. Actually, a better idea. There we go. All right. So, you see that it says untracked file, and it says run git add file to include what will be committed. But note that we're still in the master branch, and we're not bad people, so we're going to go ahead and create a branch called add rmf command, because that was the issue that we took, right? Now, we've created our branch, but you'll notice that we're still on master, and that's no good, no bueno. And so we're going to go ahead and check out the branch that we just created. If I can type, it will work great. Ahaha. Victory. So now if we see this, it says here that we're now on rmf command. But the fun fact is it didn't remove our untracked file. So if you have unstaged changes or anything and you create your branch and check it out, it's going to just kind of carry those over to the new branch. So even if you start working on stuff on the master branch, you don't have to be a bad person. You can fix it. As long as you haven't staged anything. Once you do that, right, so we're going to go ahead and remove that test file because we don't have that in our commits. But you're going to go ahead and you're going to decide that you want to write that code, right? And since I'm both lazy and think watching me code is boring, I went ahead and did that. So here we are. Hey, there we go. Okay, so now if we run git status, right, we're going to see here that it says changes not staged for commit. So the difference between the test file where it said untracked file and changes not staged for commit is with an untracked file, it doesn't care about any of it, right? Until you add it and commit it, it's not going to keep it's going to keep track of what you changed. Right, but once you've committed and added it, every single change you make, every line you add, every word you change, etc., Git knows about that, and so it can show you the delta between the two files, right? So what we're going to do is we're going to go ahead and run git add, and one of those files was cli.py. So we go ahead and we staged it now, and so we run git status. It says here, hey, you've got a change to be committed. I'm going to close this so that stops being on top. There we go. It says, hey, okay, you've got changes to be committed, your own branch or add rmf command. It says that you've modified this CLI PY, and it shows you the command to unstage it. So if you decide that you regret your life decisions and you want to go back, you can do that. So what you run now, right, is we've staged it, right? So to put it on the truck, tie it in the bow, we've got to commit it. If we want to commit, we're going to go ahead and run -v. So -v is going to show us a diff of what we changed inside of our commit message because it makes it writing it really easy. So once you do that, and this is really not legible, there we go. You'll see here, okay, here's the thing that you're committing, right? The modified CLI.py. And if you look down below, it says everything below will be removed. It's not going to be part of the commit, but here's what you changed. And you can see here we just added 4 lines, right? We added the new command, subcommand RMF. That's not particularly pertinent to the talk, but we're going to say here, add RMF subcommand, right? Note that we're less than 50 characters. It's really simple, and it's just straightforward. It's not, I added these individual lines that do all these things. So once you save and quit, Git is going to give you some output there, and it's going to tell you, hey, on add RMF command, so that's the branch you're on, it gives you this weird string, and we'll talk about what that is in a second, and then it shows you your git commit summary. Okay, so it says there that you added the RMF subcommand, and then it says 1 file change, 5 insertions. So all that is that's telling you what's on the commit, right? What that funky little string there, that DVD FFFFC, man, that is hard to say, is that's what we call the commit hash. So if you've ever heard someone say that, that's what they're talking about. And there's a much longer version of that that's in the Git database. but it uses the short hash because it's mostly unique enough to get you there. And so that's how you would reference that commit in other commands. We're not going to go over those other commands because they're hard and scary and I don't like them, but that's how you would use them. So once you do that, you notice here, okay, hey, all right, I did that, right? Get status again. Okay, hey, I've got another file here, that I got to add. So we're going to go ahead and do that. And then we're going to run get commit -v again. And then I'm going to talk about background. And there we go. So now you're going to notice, okay, this commit is a lot bigger, right? Wow, you added like 15 lines. Generally speaking, you may not want to put those all in one thing, but okay, we're going to do it. So added remove, all right, let's see, get right path, move, there we go. And remove from completion, there we go. Profile commands. And then you're going to notice there that my text editor, because I haven't configured, will actually start changing the color of the letters, right? So notice that NDS on the end there is a different color than the rest of it. That's because that means that I have surpassed 50 characters, right? Sometimes that's right to do, but most of the time it's not. Most of the time you're going to want to do a longer form thing, and so what you'll do is you'll say, okay, added, get right path, and remove from profile, right? And you say here, okay, get right path gets the path whether the file is a dot or not, and remove from profile removes the file from the file system, and profile. So this is an example of using that longer form area, right? So you put that summary in, that's what's actually going to show up in the get log, right? That longer form thing is only going to show up in the get log if someone specifically asks for it, right? The normal get log command will show you that. When we get done with this, you'll see that it doesn't show you that. It just shows you the commit hash in that first summary. So your summary should be sometimes so Spartan on words that it's, that doesn't tell you anything, right? If I know what those functions are, it tells me something, but otherwise I wouldn't know. So the longer form is what's supposed to really show you, hey, this is exactly what changed. This is exactly what happened. This is why we made these changes, right? So once you save and quit out of there, you're going to see the same thing you saw above, right? You got a new commit hash. Notice that it's unique. You have one file change, 34 instructions, and then, like I said, it only shows you that summary. Once you've done that, you'll notice now that you have get status. But what's weird is now that we're on this branch, it doesn't show us anything about origin, right? So before when we were on master, it said, hey, you're up to date with origin master. But now it's not doing that. Well, the reason for that is that even GitHub doesn't have this branch yet. So if we go back to our GitHub here real quick and we look at our branches, there's just master and develop, right? There is no add RMF command branch that we've been working on. So what we're going to do is we're going to go ahead and take our changes, all of them, and we're going to tell it to get and command. So what that's going to do is that's going to take our new branch, push it up to the remote branch with that name, and the remote there is origin. And the reason it's called origin is because Git is magical, and when you clone it, it sets a remote. But the way remotes work is they're mostly like a host file, right, or a DNS entry, right? When you go to google.com, right, that translates to an IP address. And here, origin translates to github.com, or whatever remote you want it to be. And it keeps track of its own remotes. So we have one on one of my projects that's deploy. So we go git push deploy master, and it'll go and it'll deploy that branch for us.
Now, before you push that stuff out to the origin, how can you run a difference to say, okay, what's different between what you have in your local repo versus in the origin?
So when we have this branch on the remote, right, and we'll do this to tell it to set upstream, that then will let us know if we make further changes what's different. But there is no add RMF command branch on the remote, so there's nothing for us to be different from. So we can actually show that really quick. So if we go ahead and push this up, and for some reason I thought this was a great username because I thought it was funny, but now I regret it because I have to type it every time. Oh, you gotta be kidding me. Really slow. All right, cool. So now we see that, you'll see there it says it created the new branch. All right. Now if we go and look at our GitHub, hey, it actually has already told us, hey, you've got a new branch, you might want to pull request that. So you can go and look at it and you can say, okay, now this will tell you it's 2 commits ahead of master, right? But if we want to see that locally, right, we've got to make something that's different. So if we go ahead and we'll just go ahead and do the test thing again. And then we'll show you a cool flag here, added test file. So that lets you just write that commit summary right there in the command line, so you don't have to use the text editor if you don't want. So now if we go ahead and run git status, it says your branch is ahead of origin at RMF by 1 commit, right? So it knows that the remote is at a certain state, and now it knows that you're ahead of that state. Now the trick with that though is that if someone else is pushing to that branch on that remote, right, it will not know about their changes until you pull them down. So it has no way to know how many commits ahead of them you are. Does that make sense? That's like a really pretty rare occurrence. But, so it will only know if it's been snapshotted is the best way I can explain it simply. So we go back, and here GitHub's already kind of telling us what we need to do, right? It's like, okay, you recently pushed branches, you pushed this to add RMF command, you should probably compare and pull requests. So if we want to go ahead and submit that back to the project, it says here, okay, it sets this for us. You say the base fork, and this is what trips a lot of people up, still trips me up, is that it goes right to left essentially. So we think that like our branch should be the left side, and we're putting it over here, which I guess would be the reverse for you guys, yours. But here this is the fork I want to compare against. This is mine, and I want to smush them this direction. Is essentially the best way I can. I'm going to stand like this so it makes sense. Does that help? All right. My backside's my best side. So, but the important thing to note here is that we don't want to do it to master because their contributing documentation said, hey, you should put it on develop. So we're going to go ahead and change it to develop, and we're going to compare our branch at RMF command. And it says able merge. It says that there's no merge conflicts basically, and it shows us what commits are different. And we're going to go ahead and add a comment. We're going to say like this should resolve issue number 13, 14 numbers. And once you do that, you'll create the pull request. And so then you're done at that point, right? This is the point where like if you're submitting to actual Vim, they'll always deny it because it's never good enough. And if you're submitting to someone else, they'll be like, yeah, someone help me, this is awesome. And so you'll notice here though that like some checks haven't completed yet. So this is like a cool integration with GitHub. This project doesn't actually work on Travis yet, but what this is doing is it takes the code and tests your code for you. And then if that's successful, it'll let the person know, and if it fails, and I'm sure it'll fail before I'm done talking, it'll also let the person know. So that's just something to help the project manager. Don't be scared that it's doing things automatically because it's supposed to. So now if we go ahead and we switch over to this tab, which is my actual account here, as the owner, I'm going to say, oh, hey, look, someone opened up a pull request, and you can look, and I can like go in here, and I'm like, oh, I can see, I want to see what they changed. So, oh no, they changed the UI on me. I do not like that. Thanks, GitHub. You're the bomb.
Well, that's going to be interesting.
Oh, there we go. Okay. Whew. All right, we got there. So it says here that they changed the download URL, right? And you can see that they deleted that line, added that line. That's the way the Git views changing a line, is that it's a removal and an addition. So that's why you run these merge conflicts when you guys work on nearly the same sections of code. So if I go through and I say, hey, that looks really good, right? And I wrote the code, so of course I'm going to say that. I go in here and I'll add a comment that's like, hey, thanks for the PR, you are smart and funny. And then I'll close and comment, and then, oh no, I did the wrong thing. Well, this is awkward. Oh, okay, cool, we open the pull request. All right, hey, all right. I'll merge the pull request, confirm the merge, and then the pull request is closed after that. And so then it merged into Chasing Logic Develop, right? So if we then go and look at the project that we contributed to, we can go and look at their develop branch, and you'll see the commit log will have your name. And because the email is the same for those two accounts, it says that I made all those changes. which is mostly true, but I really wanted to say definitely not Matthew Robinson. That would have been great. But here we are. So, that is contributing to an open source project. Does anyone have any questions? Because I'm not sure I could get this PowerPoint to look nice and show my questions page, but we'll try. Hey. Hey, there we go. So, yes.
So, let's say you did a bunch of work, and you made a bunch of changes, and you committed them, and then you figured out that everything you did was garbage, and you want to go back to a previous state. How do you do that?
There's a bunch of different ways to do that. So rebasing can get you back there as well. You can do an interactive rebase and undo the commits. You can do a git reset head. That is like the really dirty way to do it. It's the easiest way, but if you're working with other people, you have to force push those changes back. So if it's on only your branch and only you're working on it, that'll get you there like that, no problem. The better way, if it's only a couple changes or only a couple commits, whatever, the git revert command is the best thing. It will literally create a new commit object that undoes the commit that you tell it to undo. And that's where you would need the commit hash that we showed earlier. So it depends. Do you want a web front end or not?
What if you want a web front end?
Well, if you want a web front end, you've got to get one of the web front ends. So GitLab's open source, Gogs is open source is a good one. Git itself is its own server as well. So if there's a server that you have and you install the Git package on it and you have SSH keys set up to go to that, Git will just work. It'll just be able to let you push there, no problems. You got to do a little bit of setup on the remote side to set up the repo and stuff, but if you know where to push to, that's really easy. Getting one of the web front ends set up is pretty easy too, so Gogs is a really easy one. It's got a Docker container, you just pull it down and run it.
Okay, so the web, that Gogs you said
Yeah.
is a web front end that's freely available that you can add on top of it. Okay.
Yep, and that project's hosted on GitHub, and then GitLab itself is also open source and free to set up, but it's much more complicated, it does a lot more stuff.
I have a bunch of files which are not text files, they're audio files or other things.
You'll have a very bad time.
So, so should those be put in the ignore? How do you do the ignore thing?
So the git ignore is just in the repo, you put a .git ignore file, and then you just tell it patterns, and you can do wildcards and stuff like that, just like you would for any bash command, essentially.
Okay.
And it'll just ignore that subset of files. So if you give it a folder name, it'll ignore everything underneath that. There's tools that extend Git to work with that kind of stuff, so like Git LFS, large file storage, but merging those things is like, I have no good analogy for it. It's like shaving with a cheese grater, I guess, is the best way to put it. So,
I tried Git Annex and it was like a mess.
yeah, I have not had much luck with Git Annex. I've got Git LFS to work. I cannot say it was the best use of my time. Ben?
You gave a nice little example earlier about a spreadsheet.
Yep.
Now, if you happen to have a group of office workers using Microsoft Office tools who say, we want to have a shared directory that everyone can stick their files into and edit, you're still going to have a similar issue to what we're talking about. People aren't going to directly edit that file, they're going to keep pulling and doing their own changes. Would you say that Git would be a useful tool to give to a set of office workers to utilize as per your example?
Yeah, so we actually have a team at Kroger that does that down at what we call the GO. And I went down there for a day and I held their hand and we got them set up and got them working. As long as they know how to use it, like if you give them a nice GUI and they understand how to use the GUI or understand how the tool works, at least on a very basic level, if they know what those things mean, they're going to be great. And as a matter of fact, I know GitHub does that for their entire accounting department and stuff like that. It's really, really great for that kind of thing. The trick that I find is that a lot of people don't want to, I mean, it's a complicated tool, right? And even just what I showed here, for some people who are not already minded that way, it can be a difficult thing to get going. So once they understand it, yeah, it's amazing for that. But we also have shared drives, so. You?
one of the notes regarding that question is, I mean, the problem that you have with anything like that is merging files when there are changes, especially, Git works very well for text, and it's designed to handle text, but it doesn't know how to merge binary files.
Right.
And you need to have a tool which knows how to merge binary files. So anything that's like a Microsoft Office format, Git's not gonna support out of the box, as long as no two people have ever changed a file at the same time. However, there was one thing that I tried a couple of years ago, which works surprisingly well. It was Tortoise Git on Windows, and surprisingly, it actually is able to put Word and things like that into this merge mode where it can do that. Use Microsoft tools to do the merge, and then it merges everything. Once you complete the merge, then it's all the Git stuff under the hood. So.
Yeah, Tortoise Git's awesome. We use Tortoise Git, we use SourceTree, and both those things are awesome. The Microsoft Office file, it depends on which ones, yeah, but you're right. Some of that stuff does not play nice. Some of it does play better. But that's why it goes back to they have to know what they're doing. If they're all working off a master branch, they're gonna have a bad time and they're gonna be just give me a flash drive, right? They're gonna be miserable, and you're gonna be miserable because you're the one who has to support that. So as long as they understand branching and all that, and how to do the merges and stuff, it's not so bad. I saw a hand over here, yep.
When I go to the VI editor, and this is just the standard one, the second line has a red background to it. Does that mean anything? What does it mean?
When you mean for editing a commit message,
Yeah, with credit, but
Git Bash or on actual Unix?
actually both.
The second line from the
Yeah.
top, it's probably telling you to not put anything there.
Yeah.
Okay.
I would
It's supposed to be a
imagine.
blank line between the summary and the commit
I think they're
line.
one. Okay.
Anyone else?
Do you use Git tags for anything, or what's the use case for that?
So Git tags are really great when you're using, so we use a process called Git flow, which is just it's a branching model. There's a ton of documentation on how to use it. Git tags are really great for doing releases. So the way Git flow works is essentially you have the master branch, and that branch should never be committed directly to. That's why I said don't do that earlier. Because generally speaking, your master branch is going to be your deployed code, right? That's going to be your released code. And what you do is you create the develop branch that has all the development in it, and when you merge develop into master, that's called a release, and then you tag that, and then you can reference that really easily and say, hey, I just want to go back to version 0.3 instead of DFDDD FFF7. You can remember, oh, I have to go to that.
It's just an easier way to refer to.
Yeah, it's a bookmarking tool, really, is what that comes down to. But GitHub integrates really nicely with it, doing releases and stuff. So
Okay, so you made that new branch and did some work on it. So let's say you go a couple months and you didn't work on anything, and then you come back and you want to work on that branch, but you can't remember the name. How can you find that out?
if you just run git branch with no arguments, it'll list all the branches on your machine. Anything else?
What's the best practice for, let's say there are files that you want to keep just for yourself locally, but for a configuration file that you don't want to push to a central repository? Is Git ignore proper for that?
Yeah, that's the exact use case. So, yeah, you put things like I have customized Git configs for some of my repos so that I have different emails for different things. I keep all those in the Git ignore because I don't want to push those up.
Just warning, if you do that, remember that there's no backup for that.
Yes, yeah. If you lose your laptop, you lose that file, right? So.
It's also not tracked with your version control.
Yep.
If it's ignored, Git knows nothing about it. It's not including your commits or anything like that.
And Git status will not show it. So if it's in the Git ignore and you're like, I want to know what's untracked, right? If it's in there, it doesn't say it's untracked. It just pretends it doesn't exist at all.
There's also a private repository ignore file inside the
Yep.
directory. You don't want to keep ignore list.
Yeah. If you want your own custom ignore list, you can do that as well.
So any other tools you are using? So I saw you push the code and there's some automated job is getting run. So what do you use for that?
So for most of my open source stuff, I just use Travis. I also have a Jenkins server that does some things.
You set it up separately from Git, right?
Yeah, it's not dependent on Git. Travis is super well documented and pretty easy to get going as long as you're using GitHub. If you're using something else, you have to use their thing. So GitLab has their own CI. Bitbucket has nothing, so you gotta set up Jenkins or whatever, so.
Like what kind of things you can do, like run tests or?
Yeah. So at work we have TeamCity server, right? And every time you push your code up, TeamCity's gonna go out there, it's gonna run all your tests, it's gonna build your thing, it's gonna build your artifact, we're gonna put it into our artifact repo, and then somebody's gonna deploy that thing automatically. So that's what continuous integration is.
You ever use this in your Vagrant environments?
Yeah, so I keep Ansible, my Vagrant stuff, all that, Docker files. That's all on Git repos. So Salt, we have Salt too. So. That's in the last talk he mentioned that where if you have a Vagrant file, right, and somebody needs to approve the change when he's talking about pull requests,
Yeah.
that's where somebody would need to approve.
Yeah, we use Vagrant with Stash and Jenkins.
Okay, yeah. You like Stash? Me neither.
Eh, it's okay.
Fair enough. Anyone else? I have time. Am I getting kicked out yet? Cool. Well, awesome. If you need me, that's my Twitter. That's my email. That's my podcast. Oh, that's not my email. That's my podcast. Not as cool as my email, but close enough.